1069. Okay, what is a matrix? Raise your hands if you've never used an Excel sheet. You've all used Excel sheets. An Excel sheet? Huh? An Excel sheet is an infinite matrix. Okay? A matrix is an organized way of putting data using positions that tell you columns and rows, okay? So let's say that I've got 4, 3, 2, 1, 3, 2, 1, 0, 8, 7, 6, 4, 2, 1, 0, 1. Okay. This is a matrix. This is the first position. These are columns. Columns. Obviously, these are
rows.
Rows. Now, in Excel, the columns I think have letters, and the rows have numbers, correct? So you have a position like E1, E10, B7. Matrices work exactly the same because, in fact, Excel is a matrix. They work exactly the same way, except you put A11, position 1, row 1, column 1, A12, A13. What do you think this one is?
A21.
Okay, so you got it. A22, A23, and notice that the diagonal is always going to be A11, A22, A33. Okay? A31, A32, A33. Okay. Now, I always get this mixed up, but you have a it's rows times columns. Rows times columns. Okay, so you put rows. I'm going to put one more. 1, 4, 1, 1, 4, 2, 1, 8, 4, 3. Rows times columns. That's how you say how big a matrix is. So this matrix is how big? It is a 4 by 3. Okay? You notice that you also do that. I don't know how many have made tables when you make in Word or in Excel. Yeah. You put 4 by 3 or 8 by 2 or whatever, especially now that you're doing the science fair project, right? You use that. Those are matrices. Okay? Now, so far so good? Yeah. They don't teach you this here, but I'm going to teach it to you so you understand what this is for. When you have, for example, you remember when you had 3x plus 2y minus z equals 8, and you have 3 of these, and it was such a mess to solve them, and you have to plug into a and then the b. Okay, so let me do that. 2x minus y plus z equals 7, minus 7, and minus x plus 3y minus 8 equals 2. You would go up and down and you would start substituting and leaving by itself. This can be easily put in a matrix. You're not going to learn how to do this today, but just so you know what this is for. My matrix would look like this. First of all, I have all my x's aligned, all my y's aligned, and all my z's aligned.
You're missing a z on the last one.
So this would look like this. 3, 2, minus 1. 2, minus 1, 3. I think you got it. Minus 1, 1, minus 8. 8 minus 7, 2. I have simplified all of this. It is understood that these are the x's, these are the y's, and these are the z's, and these are the answers. Eventually, you will learn how to find x, y, and z with just this without writing x, y, and z. Okay? Right now, we're not going to learn that. Right now, we're only going to learn something called determinants. So I'm going to erase. If I can only find to erase something to erase with.
Get a tissue.
I've got this.
Behind the tissue.
Okay. Is it clear what a matrix is?
Yes.
Okay. And now, did you ever watch The Matrix?
Yes. Oh.
Now you understand what why it was a matrix, because you had, that's why you would see all the little rows, because in the end, and all, just like you create video games, you create an alternative world with just numbers, right? With the matrix. Okay. Got off.
Can we dodge bullets now?
Huh? The matrix.
Can we do?
Okay, so now we've got the matrices. Now we go to determinants. Now, this book, in this chapter, you are only going to work determinants of 2x2 matrices. Okay? Matrices. You can do determinants of matrices that are 8x8. It's complicated, but you can. And you can do 3x3s. You can do all sorts of different. This one only concentrates on 2x2s. With your luck. Because the longer they get, the bigger they get, the longer it gets. Now, could somebody read page 4? Oh, I'm going to read it out loud. If a matrix has the same number of rows as it has columns, meaning 3x3, 2x2, 4x4, the matrix is a square matrix. Guess why?
Because it's square.
Because squares have equal lengths on both sides, okay? If a matrix is not a square matrix, it does not have a determinant, okay? Every square matrix is associated with one real number called a determinant. It's a number associated with it. I will show you how to find that number associated with it. The determinant is used later on to find the solution to x and y using determinants and the matrices, okay? So, if I have A, B, C, and D.
You're gonna multiply D times A.
Before I forget, the symbol for matrix is a giant parentheses or a giant bracket, or when you get lazy like me, it looks like absolute value, but it's not. Okay, just so you know. Just to get to a point where I get tired. Okay, so you do. The determinant is found by
A and D.
sort of. This one goes down first, and this one comes up second. Okay? So it's going to be, the determinant of this is A times D, AD, minus CD,
CB.
CB. That is the determinant. So if you have 4, 3, 1, 0, this will be first 4 times 0 minus 3 times 1. The determinant for this one will be minus 3. Okay? It's the number associated with this matrix in particular. Got it? If you want to go further, which you could, if you have a 4 by 1, 0, 3, 1, 2, 8, 0, 1. This is a 3 by 3. What would you, we'll see this later, but just so you know that you can, it's the same thing. It's this one, but now you have more. So you have to do this one, and this one, minus this one, and this one. And you're going to say, but there's no numbers here.
Well,
You
what
copy
happened
this
to
one
the
again. We're going to do 3 later, but I'm showing you now that you can do it with 3, and it's the same exact method, okay? We're not going to do 3s now.
No.
You're only going to do 2s. Okay, so, is it clear how to find the determinant? So if they tell you to find x, and they give you a matrix that is a 2 by 2, see the positions?
Yes.
They're a little crooked, but x plus 4, 6. Okay, those are the positions. And they tell you that the determinant is minus 5. You have to find x. How do you find it?
X minus 4 times x Plus 2 minus 3 times 5 equals
X plus
95.
4 times X plus 3 minus 5 times 3
Minus 5 times 3
equals -5.
equals -5. And you find x. Okay?
X plus
We cool?
6 plus 8.
Everybody understand why it equals -5? Because that's the determinant. So we use it this way. Questions? No?